right, plan for this recording is to talk through two topics. It's going to be kind of long, but that's all right. We're going to go through properties of logarithms and solving exponential and logarithmic equations. So that's kind of the plan for today. So let's get rolling. If you have not copied this down, you want to hit pause and copy that down so that we can use those and refer back to them. So I'm going to give you a second, hit pause, and copy down those properties. Okay, one question on your test, one skill you need to be able to do is expand. The directions for this will be expand, and it might have some more words, expand the given logarithms, but the key word is expand. When I expand, kind of the rule is there's only one variable inside of each log and no exponents. When you expand, you know you're done when you have one variable inside or term, it could be a number, inside of every log with no exponent. Okay, so if I look at this right here, log base 3 of x times y. Product rule. If I have the log of two things being multiplied together, I can take the log of each one separately and add them together. So this would be written as the log base 3 of x plus the log base 3 of y. Notice where these are located. All of this top part is on the same line. The only subscript I have is my base of 3. Everything else is on the same line. Okay, jump over here. That was using the product rule. Why? Because it's the product of two terms. I'm taking the log of two things that are multiplied together. Okay, quotient rule. What if I have two things being divided? Well, I can take the log of each one individually and subtract them. Top minus bottom. Once again, that whole top part is on the same line. It's the log of x. It is not 4 to the x power. It's the log of x with a base of 4. The log has a base of 4, not the x. Okay, let's put a couple things together. So this looks like product rule to me. I have two things being multiplied together. Give you a second. How does that expand? Okay, I'm going to write that as the log base 2 of x squared plus the log base 2, same base, of y to the third. Now these are exponents of the x and of the y, and the only subscript down there is the 2. Okay, I'm going to jump down here to power rule. Power rule says if I take the log of something that's being raised to an exponent, I can move that exponent out in front. The power rule says if I'm taking the log of a number or a term being raised to a power, that power can come out in front. So this 2 can come out in front, and I have 2 log base 2 of just x. That 2 comes out in front. Same with the 3. The 3 can come out in front, and I can have log base 2 of just y. And I've satisfied my rules. There's only a single term inside the log, and there's no exponent. Your turn. If you need to hit pause, if you're not quite done yet, go ahead and hit pause. I'm going to divide that. Or sorry, I'm not going to divide it. It's already divided. I'm going to subtract that. Why? Because my rule says if we have the log of something divided by something, it's the log of each one individually subtracted. Remember ln. ln is simply another way of writing log base e. So this is log base e of x to the fourth. I don't need to write log base e. If you would like to switch them, you can, but I highly encourage you to get comfortable with seeing ln. It's a natural logarithm. That's what it's called. Okay, so this is log base e, just like this is log base 2 of x squared, this is log base e of x to the fourth. I just don't need to write that there. Don't know why it did that. Okay, so 4 comes in front, and I have 4 ln of x minus 5 ln of y. These are all on the same line. There's no subscript, and there's no exponents. Okay, not the way I wrote it. I could write that. Again, I don't recommend this, but I could write that like this, and now I would have a subscript. These are the same expressions. That's much easier to write. Why would I want to write this when I can just write that? But that's what it means. This and this are the same thing. Okay. Don't really want all that. Okay. Definitely hit pause. This will take you a second. Hit pause and see if you can expand that. Okay, hopefully you're back. So we have log base 2 of x squared y minus log base 2 of z to the fourth. These are all on the same line. The only subscript is the 2. The exponent is the 2 and the 4. Okay, I have another expansion to do. This is 2 terms being multiplied together. So I can write that as log base 2 of the first plus log base 2 of the second minus log base 2 of z to the fourth. Whoops, I don't really want to do that. I'll make a mess. All right, next step. This 2 can come in front. This 4 can come in front. Final answer, 2 times the log base 2 of x plus log base 2 of y minus the 4 can come in front. 4 times the log base 2 of z. And we're done. All right, last one. Kind of a mess. Hit pause, give it a try. Okay, notice there is no base written. Remember, when there's no base, it's an implied base 10 called a common logarithm. So I don't need to write anything in the subscript. So I'm just going to expand that. Log of the square root of x plus the log of the cube root of y minus this entire term on the bottom. Well, I don't need the parentheses yet. I will in a second. Minus log of z to the fifth plus, well, I'm not going to skip a step. So we have that. Okay, so the top, well, I kind of skipped a step here. Are we okay with the, I guess you can't answer me. I'm not going to skip any steps. You may have been okay getting to there, but some of you may not. So this is the log of the square root of x, the cube root of y. Log of this minus, because it's divided by, the log of this. Now I'm going to separate that into the log of the square root of x plus the log of the cube root of y minus parentheses, because I take one term and I'm changing it into 2 terms, so I need the parentheses. And this is a plus, right? This is a log of 2 things being multiplied together, which is a plus. But the minus out here goes to this entire term. And this entire term is now represented by these 2. So I need the parentheses. Technically, you have a parentheses here, but I don't need them because there's only a positive 1 in front of that. And 1 times anything is just that thing. Not true over here. A negative 1 times something will change its signs. So that's why I need the parentheses over here. Okay. How do I write the square root of x with an exponent? Well, the square root of x can be written as x to the 1/2 power. And the cube root of y I can write as y to the 1/3 1/3 power. So I'm going to bring these 1/2 and the 1/3 in front and rewrite this as 1/2 log of x. So now I'm down to just a single variable with no exponent, plus 1/3 log of y. This negative sign makes this a negative, so minus, going to bring the 5 in front, going to bring the 4 in front, and this negative makes this also a negative. Okay, there you go. There is expanding logarithms using our log properties. Okay, let's go the other direction. I'll do the first one and you get the next two. So I want to make this expanded logarithm go back to, so now we're going from here back to a single logarithm. Okay, start from the expanded form, and the directions for this will be to condense into a single logarithm. Okay, so this exponent, just going backwards, this can go up to here, this is going to go up to here. So this becomes the log base 3 of x squared. And now this addition, where'd it go? Like this addition here will become multiplication. This will become x squared times y, because it's addition, which means when I put it into a single log, it becomes multiplication. Okay, think about how we did these up here, and you try to condense this mess into a single log. Get as far as you can. Don't just keep rolling the video. You try. Practice is the only way to get better. Okay, I need to rephrase it. It's not the only way. It's the best way, in my opinion, to get better. All right, so I'm going to bring this 3 up in front. Log base 4 of m to the 3rd. Let's go ahead and condense these. I'm going to bring this one up here, n squared, and it becomes multiplied just like I did right here. So I've done this first part right here. And I'm not going to skip, I'm not going to do another step. I'm just going to write that out. Okay, now I'm going to do this condensing. Single logarithm, base of 4. The first term goes on top, and what I'm subtracting goes on bottom. Okay, your turn. Try this mess. I'll give you a hint. Look at this big messy one over here. Look for similarities as to where different terms go from here, or when I go from here back to here, where did the different terms go based upon the sign of the term? Where did this positive go? Where did this negative go? Or where did it come from? Okay, give it a try. Hit pause, give it a try. Okay, I'm just going to rewrite everything again. Notice there's no base now, so I just have an implied base 10. I'm going to rewrite all of these, putting the exponents in the top. Let's do that first. Oh, something happened here. I'm going to make that a W. I don't know where that went to. It should have been a W or a something up there. Okay, now let's do what we did up here. Notice all of the terms with the negative sign were on the bottom, because when I distribute that negative sign, it makes them all negative. So my shortcut is, if a term has a negative log, it'll be on the bottom. If the term has a positive log, that'll be on the top. So I'm going to write one single logarithm, implied base 10 down here. My positive logs will go on top. So this is going to be x to the 1/2 w squared. My negative logs will go on the bottom. I think you know what I mean when I say negative logs. I'm not bringing the log to the bottom. I'm just bringing the term that's in the log that's negative to the bottom. I'm done. Okay, that is condensing and expanding. Homework was page 327. You can do that either now. You can hit pause, hit stop. Well, probably not stop. Hit pause and go give those a try for probably 25, maybe 30 minutes, but probably more like 20, 25 minutes. And then come back, or you can just keep on rolling, and we are going to move into solving. Okay? So either way, either hit pause and go and try those questions first while it's fresh in your mind, or just keep on rolling. I'm going to keep rolling. Okay. We're not totally switching gears, but we're going to use properties of logs now to help us solve sometimes. Okay, so in this first setup here, notice my bases of the exponents are the same. I'm trying to figure out when will this side equal this side. So 4 to what power will equal 4 to what power? Well, the only way that those are the same is if the powers are the same. If my bases are the same, my exponents have to be the same in order for this to be truly equal. So I just write a little equation and set the exponents equal, and I solve it. I'm going to add 1 to both sides, and I get 2x equals 5x plus 3. Subtract 5x, and I get a negative 3x equals 3. Divide, and I get x equals a negative 1. Okay, so if I put a negative 1 up here, I would get the same answer. So one setup would be my bases of my exponentials being the same. If they are, just drop the bases and set the exponents equal. Well, the other setup is if the bases are not the same, but I can make them the same. So I'm going to leave the 6 alone. Well, the question I'm going to ask myself is, can I make, or what do I need to do to make the bases the same? Well, if I make a 6 a 36, I've changed its value. I've squared both the top, or I've squared this side, but done nothing to this side. So what I'm going to do is I'm going to change the 36 into a 6. 36 is 6 squared. I have not changed the value of 36. If I square this side to make the 6 a 36, I've changed its value. Okay, so now the 36 is being raised to a negative x plus 1 power. Now, when we have a power raised to a power, what do I do? If I had x to the third raised to the 4th power, what do I do with those two exponents? We multiply them, and I get x to the 12th. So this one I'm going to multiply here. Leave the left side alone. 2 times a negative x is a negative 2x. 2 times 1 is 2. Now my bases are the same. I'm right back to question 1. And I'll take my exponents, which is 2x minus 1, and I'll set it equal to the other exponent of a negative 2x plus 2. Add 2x to both sides. Add 1 to both sides. I think we are able to skip steps, or do 2 steps in 1. Divide by 4, and I get x equals 3/4. Okay. They're solving when you can make the bases of the exponents the same. What if I can't? And here's where we're using our properties. So let's go back. I'm just going to throw a whole new problem out here. What if I gave you x squared equals 25? How do you solve that? Hopefully you said you take the square root of both sides. Why would I do that? Because a square and a square root are inverses of each other. The one undoes the other. So if I square root this side and I square root this side, the square and the square root are going to cancel, and I get plain old x. That's what I want. I want to know what x equals. What if I gave you the problem? We have it right up here. 4, where to go? 4 times something has to equal 3. How do you get rid of multiplication? You do the inverse. We divide both sides by 4 to both sides. Okay, so how do I do this here? I do the inverse operation. To get rid of an exponential, to get the x out of the exponential so I can solve for it, I'm going to use a logarithm. I'm going to use an exponential's inverse, just like we did with the square and just like we did with multiplication, division, addition, subtraction. It's the same exact concept. So I'm going to take the log of both sides. What base do I want to use? I can take the log using any base I want. Our calculators have base 10 and base e programmed into them. So I'm going to use one of those, and it really doesn't matter which one you pick. However, if there's a 10 here, I'll use base 10. If there's an e here, I'll use base e. If it's something else, you get to pick. In order to know what log to use, it doesn't matter. However, if it's a base 10, using a base 10 log will make it a little easier. If it's a base e, using ln, your base e log. And if it's something other than 10 or e, you pick what you want, and it doesn't matter at all. Okay, I'm going to take the common log. I'm going to do log of 10 to the x, and I'm going to do log of 33. Taking the log of both sides, just like I square rooted both sides. Same thought process. Okay. Using my properties. Remember, if there's a variable or there's an exponent, I can bring the exponent out in front. So I can write this as x log of 10. What is the log of 10? And here's where it's nice to have the right, not the right base, the 10 base. Remember, this is base 10. Remember, this is asking the question 10 raised to what power is 10? 10 raised to what power is equal to 10? Well, the only way that's going to happen is if y is 1, because 10 to the first is 1. So the answer to this right here is 1. So this just becomes 1 times x, or x. And that's where it's nice, because that kind of goes away. If you did not notice that, my next step right here would be to divide by the log of 10. Why? Because the log of 10 is just a number. And just like up above when we had 4x equals 3, you divide by what you're multiplying to get rid of it. Same thing. So if you did not notice that the log of 10 is 1, just divide by that number. Grab your calculator, type in log of 33. When you do that, your calculator is going to give you a parenthesis here. You must close it before you hit divided by log of 10. Otherwise, it'll consider that all still inside the log. Just make sure you close that number. Okay, once you type that in, answer should be, I get about 1.519. Make sure you get that same answer. And if we did the log of 10 equals 1, then just do the log of 33, and you will get the same number. Okay. Once you get this, hit pause. I'll give you a hint before you run away. I want to isolate the exponential term. I want to isolate the exponential term. Then I do this, and I switch, or I take the log of both sides and solve. Okay, go. All right, so to isolate this, I need to undo this multiplying by 4, so I'm going to divide both sides by 4. 3 raised to the 6x needs to equal 6. That's 24 divided by 4. Okay, just for the fun of it, I'm going to use ln. So I'm going to take the natural log of 3 to the 6x equals the natural log of 6. If you use log, you will get the exact same answer. Okay, like we did here, this exponent can come in front, this exponent can come in front, and I get 6x ln of 3 equals the ln of 6. I have 6 and ln 3 being multiplied by x, so I'm going to divide by both of them on both sides. That goes away. That goes away, and I get x equals the natural log of 6 divided by 6 natural log of 3. If you want to do them individually, you can divide by 6 and get a number, and then take that number and divide by the natural log of 3. That is totally fine. What I mean by that is, so I'm going to divide by 6 first and not divide by the natural log of 3. Just divide by 6, and that works fine. And so I'll get x ln 3 equals whatever that number comes out to be, and then I'll divide that number by the ln of 3. That works fine also. Okay, so if you like that better, you can do that. Okay, I guess I'm gonna go hit, I don't have that one typed out. I'm gonna hit pause and go type it out. So when I do that, I get 0.272. 3 decimal places is a good rounding spot. All right, those are solving exponentials. Let's switch gears. Let's solve some logarithms. So just like the exponentials, sometimes you're going to have the logs the same. Natural log of 2x minus 4 has to equal the natural log of x plus 6. The only way that's going to be true is if what I'm taking the log of is the same. So if your bases are the same, you have just log equals log, I can just drop the logs and set the inside equal to each other and go through my nice algebra solving, and I get x equals 10. Okay, what if they're not? Now, I've seen this described or explained 2 different ways. I'll show you the way I do it, and I'll show you the way I've seen a lot of other people do it. And I like my way, obviously, because that's the way I do it my way. So here's what other people do. They're going to do just, and I know why they do it, but it's super confusing, but I will explain it first, because you may YouTube some stuff and you find this. So just like we take the log of both sides to get rid of the exponent, they're going to raise both sides, and they're going to go 3 to this power and 3 to this power. Why'd I choose 3? Because of the base. They're going to take and raise this or use an exponential to solve it. And if you remember back from some of the messy ones we did on the board, when you have the base of the log and the base of the exponent being the same, your answer is just this. Okay, that's what some people do. That is not what I do. Here's what I do. I simply switch forms. So it sounds like I'm doing something different than taking both sides to an exponential or an exponential to both sides, but I'm not. I'm using an exponential to solve a logarithm. I'm going to switch this form. The base of my log is the base of my exponent. The answer to my log is the exponent. And I'm going to get that there. Notice it's exactly what I would have got had I raised the 3 to that power and the 3 to that power. I get the exact same thing. This is just way less confusing in my opinion. I just switch forms. Okay, so 3 to the second power equals 2x plus 1. Remember way back when we defined what is this thing called a logarithm? Log base 8 of 2 is asking the question 2 raised to what power equals 8. That's all I did. I just switched forms. 3 to the second has to equal that. What is 3 to the second? Well, it's 9. And now I have a nice, easy linear equation to solve. I subtract 1, I divide by 2, and x equals 4. Okay? Your turn. Try the next one here, and you ask yourself the question, does it look like this, or does it look like this? And I'll give you a second to solve. Or you hit pause and solve it as long as you need to solve it. Okay, the bases are the same, the logs are the same, so what's inside has to be, whoops, the same. And I just drop the logs and I set them equal. Do my solving, divide, and you should get -4. Okay, your turn. Does it look like this problem, or does it look like the one up above? Hit pause, give it a try. Okay, I'm going to switch forms. It does not look like this. It's not log equals log. It's log equals a number. So I'm going to switch forms. 3 raised to the second power equals x squared plus 9x plus 23. 3 to the second is 9. But now I don't have a nice, neat linear equation. I have a quadratic equation. But that's okay. We're in honors algebra 2. We can handle exponential equations. How do you solve a quadratic? I said exponential, didn't I? I meant quadratic. How do we solve a quadratic? Well, we have options. We can factor it. You could quadratic formula. You could complete the square. You have options. I'm going to try to factor, which means I need this equal to 0. Even if I quadratic formula'd, is that a phrase? Even if I use the quadratic formula, I would still need to set it equal to 0. So either way, I need that 0, so I'm going to subtract 9 from both sides. I'm just going to take 30 seconds and see if I can factor this thing. If I can't, I'm going to quadratic formula. If you like completing the square, go to complete the square. Okay, so I need x squared, so I get x and x. Factors of 14 that add to 9, 7 and 2. I didn't need to go through the big mess of quadratic formula. It factored nice and easily. Answer is x equals a negative 7, x equals a negative 2. Now, super important. At this point in time, because we have this x squared, we could have a value for x that is not possible. What do I mean not possible? Remember back when we did what is this thing called a logarithm? We have, what is the log of negative 8 base 2? 2 raised to what power equals a negative number? Not possible. 2 raised to the third power is a positive 8. 2 raised to a negative third power is 1 over 8. There is no way I'm going to take a positive number, raise it to anything, and get a negative number. It is not possible. So when I say I could generate a number that is not a solution, I have to take this negative 7 and plug it back in and make sure I don't get a negative number. So if I plug a negative 7 in right here, negative 7 squared is 49. 9 times 7 is 63, plus 23. 49 plus 23 is 72. 72 divided by, or minus 63 is 9, and I'm taking the log base 3 of 9, and that does equal 2. Okay, first one works. That does not mean the second one works. So I have to go through the same process. Now we're going to take the negative 2 and plug it in. So negative 2 squared is 4. 9 times 2 is 18 plus 23. 23 plus 4 is 27, minus 18 is again 9. We know it works because we just tried it. They are both solutions. Okay, you get the next one. All right, now we're going to use our properties. I want to make this a single log before I can do this, before I can switch forms. It has to be a single property, not single property, single logarithm. So I'm using my properties to combine these. Well, I have the log base 6 of 3x plus. So I'm going to write that as a single log of 3x times x minus 1. Because this is a plus, remember from the earlier part in the video, these two condense into a single logarithm being multiplied together. Now I'm going to do what I did over here. Switch forms. 6 to the third power equals this mess right here. I have a quadratic. I'm going to solve it. So if you got stuck and couldn't get to here. Now that you're here, see if you can solve that quadratic. First step, I'm going to work out the left-hand side. So 6 times 6 times 6 is 216. 3x times x is 3x squared. 3x times a negative 1 is a negative 3x. I have a quadratic. If I want to use quadratic formula, or if I want to factor, it's got to be equal to 0. So I'm going to subtract 216 from both sides. That's a 6. I'm just going to ask myself the question real quick. Does 3 go into all of these? Yes, it does. This goes into it evenly one time. This goes into it, whoops, one time. And this goes into it 72 times. Okay? Now, does it factor? I'm just going to take 10 seconds, well, maybe 30 seconds and see. Factors of 72 that subtract, up here we added because it was a positive, now I'm subtracting to get 1. Well, that would be a 9 and an 8 because 9 minus 8 is 1. But I want a negative 1, so this one's negative and this one's positive. 9 times 8 is 72. 9, negative 9 plus 8 is a negative 1. Okay, solving that, x equals 9, x equals negative 8. If you are not a factorer, you can't factor to save your life, then go to quadratic formula. Just plug that into the quadratic formula. It just is a lot of chances of making a mistake if you don't know how to factor. Okay, I got to check my work. Take this 9 and plug it back in. Does a 9 make either one of these factors or terms inside the log negative? 9 times 7 is a positive number. We're good to go. 9 minus 1 is a positive number. We're good to go. Plug in negative 8. 3 times negative 8 is a negative 24. Not good to go. That goes away. If it makes either one of these negative, it doesn't work. Not both. It has to make either one. It doesn't matter which one. It could make them both negative like this, but it only has to make one negative because you can't take the log of a negative number. Okay, so that one's gone. Answer, x equals 9. All right, last one. Give it a try. Okay, I'm going to use my properties to condense that mess, and I get the log. Whoops. I get the log base 5 of x plus 4 times x plus 1 equals 2. That times that in a single logarithm. Switch forms, 5 to the second power equals x plus 4 times x plus 1. Wow, my writing's getting horrible. It's been a long video. All right, 5 squared is 25. And I'm going to distribute that. I'm going to make your box, do whatever you got to do to FOIL that out. And I get x squared plus 5x plus 4. And I just distributed these. I FOILed these. I did the box, whatever technique you are doing to multiply that out. Okay, it's a quadratic. I'm going to set it equal to 0. I'm going to take 10 seconds and see if I can factor. Factors of 21 that will subtract to give me 5. Doesn't happen. 7 minus 3, nope. 21 minus 1, nope. I can't get 5x, new plan. But I always want to do that because it saves me a lot of work if it does work. And it took 10 seconds. All right, so my next step is I'm going to do quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Grab your calculator, type it all in, and when you do so, I get x equals 2.72, and I get x equals a negative 7.72. Plugging in 2.72 into this x gives me a positive value. Plugging in 2.72 to this x gives me a positive value. This one works. Plugging in a negative 7 does not work. That goes away. This is my answer. All right, there is solving exponentials and logarithms. And properties of exponents. You can now do page 327 and page 334 in the homework. Good luck. Hope that helped.